Hi everybody. In this lesson, we're going to talk about curve sketching. So this is taking what we've learned about the first derivative and second derivative and to graph a function. So if we didn't have a calculator, we could use this and we could get a rough approximation of what it would look like. Before we get into that, of actually graphing, let's talk about the different features of a graph and how they'll show up on the function, first derivative, and second derivative. So if something's increasing and concave up, it would look like this. The first derivative would be positive if we're increasing, and the second derivative would also be positive for concave up. If we're increasing and concave down, it would look something like this. The first derivative would be positive because we're increasing. The second derivative would be negative because we're concave down. Decreasing and concave up would look like this. It's the partner to that one, if you think about it like a parabola. Decreasing would mean a first derivative down, and concave up would mean a second derivative of up, or positive. Decreasing and concave down would be the second half to this one. Decreasing would be negative, concave down would mean the second derivative is negative. A local maximum would look like this. That would be when we have something that's concave down. So that means the second derivative would be negative. And it occurs when the first derivative is 0 or undefined. The local minimum looks like this, which would be concave up, a second derivative that's positive, and the same thing when the first derivative is equal to 0 or does not exist. Just a quick note, notice how often I'm saying first derivative or second derivative or the function, and I'm not using the word it, and I'm not using the word slope, because those can be ambiguous. So use the word function, the derivative of the function, the second derivative of the function, avoid it, slope, those concepts. A point of inflection that goes from up to down could look like this. Concave up to concave down. It could also look like this. And those aren't perfect, so you always can mark them and write in what they are. Those are 2 points where the concavity changes. The first derivative is going to be equal to 0 or undefined again at those locations. You can see there's a slope of 0, or this would be a vertical tangent, which would mean a slope that's undefined. And the second derivative would be equal to 0 or undefined at those points as well. If it goes from concave down to concave up, that would be one example. And there would be the other example. Again, when the first derivative is 0 or does not exist, and the second derivative is 0 or does not exist. So now let's flip and try to apply these concepts.